Um, for now, we're doing in 9.2, we're doing something called separable differential equations. So you have a differential equation right here. Now, why is it a differential equation? Because it is a function, it contains the function, y is the function, and it also contains a derivative of y. So it has a y and a y prime in the same equation, hence it is a differential equation. We're also going to make this an IVP that we're giving you that y of 0 is equal to 4. So what we're going to do is first we're going to find the general solution, and then we're gonna use this information to find the particular solution. Anyway, in a problem like this, when it's a separable differential equation, it's easier to write, instead of writing y prime, it's easier to write dy dx. So I'm not changing anything. I'm just writing, instead of y prime, writing dy dx. And the reason I wanted to do this is because now we're going to cross multiply. And when we cross multiply, we're going to get something like this. That I bring the y over here, I bring the dx up over there, so y dy equals negative x dx. And if these two things are equal, then I could take then the integrals are going to be equal. So I'm going to integral each one. And pow, there's the integral signs. Notice how I just say it and it happens. It's camera magic. Well, now I'm going to integrate. So I'm going to integrate. The integral of y is y squared over 2. The integral of negative x is negative x squared over 2 plus c. I don't bother with the plus c on this side. I just put a 1 plus c at the end. It doesn't really matter because I have a constant there and a constant there. I may as well just combine it into one constant. Anyways, the truth is we've actually solved the differential equation, because as long as we've gotten rid of all the y primes and all we have is x's and y's, this technically is the solution to the differential equation. I'm going to put it, though, I'm going to solve for y and just do a little algebra. And I get, of course, I'm going to multiply everything by 2. And notice when I multiplied everything by 2, I don't write 2c. The reason is because when I multiply a constant by 2, it just, the 2 kind of gets absorbed in the constant. I just have a new constant, but it's a constant. Now, sometimes I think in the textbooks you'll see they'll call this C1, they'll call that C2. I'm not going to bother with that. It's just, just keep it simple. And now I'm going to square root each side, and I get y is equal to plus or minus square root of negative x squared plus c. And that is the general solution. Which one is it? Is it plus or is it minus? Well, that's going to depend. Funny you should mention that. Let's look at the initial value. So they're giving us now an initial value that y of 0 equals 4, which means if I plug in 0 for x, I'm going to get 4 for y. And that's going to give me 4. So y becomes 4, x becomes 0, so this is just negative 0 squared, so just 0 plus c equals 4. And that means that c is equal to 16. And now I could rewrite my particular equation, y is equal to negative x squared plus 16. Now, how come here's plus or minus, and now I kind of dropped the plus or minus. So why did I do that? The reason is, once I know that y is going to be a positive number, this is going to be positive 4, so it's got to be the positive square root, not the negative square root. And the initial value really told me that. By the way, does anybody recognize what this equation is right here on the bottom? This equation is a circle with radius 4 and center of 0, 0. In other words, y equals square root of negative x squared plus 16 is a circle. The radius of the circle is 4, the center of the circle is 0, 0. In fact, this also, any of these, that's a circle, that's a circle. These are all circles. This here, the plus is the upper, when you have this, by the way, I shouldn't have said circle, it's really a semicircle. The plus would be the upper half, the upper semicircle, and the negative would be the lower semicircle. And that, my friend, is how we do that. Separable differential equations.